Okay, so question 7 was a coordinate geometry question. And part A says write down the coordinates of the airports or S and T. So let's start with or. So there's or there. It's 1 on the x-axis and 1 on the y-axis. So that is, I just might actually use a different color. 1, 1. Okay. Let's have a look at S is the next one. -2 on the x-axis and 3 on the y-axis. So -2, 3. And then for T, 4 on the x-axis and -1 on the y-axis. So it's 4 minus 1. It says use coordinate geometry method to show that airport or is exactly halfway between airports S and T. So halfway should have triggered in your head the minus, or not the minus B formula, the midpoint formula, which you should have gotten in your log tables. And remember, you get marks just for writing down the formula. And the formula is add the x's, x1 plus y1, sorry, x1 plus x2 over 2, y1 plus y2 over 2. All right, which is going to be, so let's fill in our y1s. So we're trying to find halfway between S and T. So this will be my x1, this will be my x2, this will be my y1, this will be my y2. All right, so filling those values in, x1 is -2 plus x2, which is 4, divided by 2. All right, and y1 is 3 plus -1, so that's -1 over 2, which is going to give me 2 over 2 and 2 over 2, which is the same as 1 over 1. Okay, I'm not going to show you, there is a different way you could have done this. You could have used the distance formula, and you could have found the distance from S to or, and then found the distance from or to T. And if they're both the same number, then or must be halfway. But it's much easier to use the midpoint formula. Okay, so part C says find the length of ST, the distance between airports S and T. So the distance formula is y2 minus y1 to be squared plus x2 minus x1 to be squared. All right, so that's the formula that we're going to use. And it's the distance between S and T again. So our x1, y1 labels are still okay. So let's fill them in. So we'll start with y2 minus y1, which is going to be -1 minus 3 to be squared plus y2 or x2, which is 4 minus -2. So it becomes +2 to be squared. All right. When you do that, so -1 minus 3 is -4, and -4 squared is 16. 4 plus 2 is 6, and 6 squared is 36. Okay, add those together, you get the square root of 52. So that's the distance there. All right, is the square root of 52. On a scale, the map is 1 grid unit length, which is 450 kilometers. If a plane flies at an average speed of 600 kilometers an hour and takes the most direct route, how long would the flight from airport S to airport T take? Give your answer correct to the nearest minute. Okay, so we need to scale up. So we have found that the length is the square root of 52, and we need to scale that up to the real world, which you do by multiplying by 450. So the square root of 52 multiplied by 450 gives me 3,244.996. Well, you know what? Well, we'll keep it at that for the moment. 996,148. 996,148. Okay, so that's the real distance. All right, so we have distance in kilometers and we have a speed of 600 kilometers per hour. So remember Dad's silly triangle. We want to find the time. The time is going to equal distance divided by speed. So we're going to divide 3,244.996,148. We're going to divide that by 600. Okay, so I'm going to divide that by 600, and it gives me 5.408326913. Okay, so it's 5 hours and a bit, but working out what that bit is, well, remember that hours are split up into 60 minutes. So if I take that 0.408 and multiply it by 60, so on my calculator, I have this number written in. I'm going to take away the 5 hours, and it leaves me with this decimal place. I'm going to multiply that by 60 to get what that is in minutes. And it's 24.49 minutes, right? So that's the same as 5 hours and 24.49964996 minutes. Well, I'm going to round that. It's 5 hours and 25 minutes. Okay? Because the 6 changes that to a 0, changes that to a 0, changes that to a 5. Okay? So you get 5 hours and 25 minutes.